So in this part, we will look into the first, like, and the simplest file system, which is file allocation table. This was first introduced by Microsoft, and Microsoft, I guess, it still owns the patent for it, and it actually earns a lot of money from Android phones, which which use FAT as their default file system. So one of the important advantages of files is file allocation table was it's very simple and it's very easy to implement. That's the reason it is used in, like, even in smartphones, and where like the simplicity is preferred. Similarly, on thumb drives, in most of the other devices, it's usually FAT is the default file system, and it's heavily used on Windows systems as well. And the key data structure in file allocation table, sorry, in FAT file system, is file allocation table. So here, file allocation table is just the list of all the disk blocks on, that's it, in the disk. And a file, in case of FAT file system, is a linked list of disk blocks. Okay. Now, now in order to know what are all the disk blocks corresponding to a file, there has to be a linked list maintained in FAT file system, right? That is the novelty of FAT table, or like file allocation table. So here, what happens is a file allocation table. For each disk block, there is an entry in file allocation table. So for, let's say, a disk that has 31 blocks, there are 31 entries in the file allocation table. Okay. So each file, or like each file allocation, each entry in the file allocation table corresponds to one disk block, and each entry also has a pointer to another entry in the file allocation table. So here in this example, for instance, let's consider file A. Okay, so here file A, note that the first block is 10. So if you go to entry 10 in the file allocation table, so entry 10, which says that the first block of file A is block 10. Okay, and then in entry 10, the there is a link to the next block of that file. So the link is to block 3. So the next block that corresponds to file A is block 3. So now if we go to block 3, that is the second block, there we see entry 12. So that means 12 is the next block that belongs to file A. So when we go to the block 12 ends with 0, which says that the file ends there. Okay. So now, as you can see, file A, like the blocks 10, 3, and 12 belongs to file A. Okay. And we only store the first block of file A, and FAT, like file allocation table, helps in maintaining the links to all the blocks of file A starting from the first block, which is block 10. Okay, so that's how for all the files in FAT file system, we only store the first block. Okay, and then once we know the first block, we can refer the file allocation table entry corresponding to that block and traverse the links to find all the blocks that belong to each file. So the slide shows, you can see the color mapping between the files and the corresponding entries in the file allocation table and corresponding disk blocks. Okay. So here free list, or like free blocks, are again maintained through a list, through a linked list, where we just store the link to the first free block, and that'll store link to the second free block, so on and so forth. So now this has various advantages. First, it's very easy to find free block. How? Just go to the first entry that corresponds to the free space, right? So here, if I have to find free block, I'll just go to the free space, like the first entry that is pointed by the free list, which is 4. I just get the 4, right? And once I get the free block 4, I update the free list to point to the next block, which is block 5. That's it. That's how I get a free block. It's very easy. And it's very easy to append a block to a file as well. How? We just traverse the list of the files, and then we go to the end of the list. There we take the free block and modify the last block to point to the new block and make the new block point to 0. That's it. It's very easy. How to delete a file? It's very easy. Again, if let's say if I have to delete file C, what I'll do is I'll remove the entry in the corresponding directory, okay, and I will take block 20, okay, and I'll just add that to the end of the free list. That's it. Because since block 20 has links to all the blocks that belongs to file C, I don't need to delete all the links. I just need to update like my free list, the end of free list to point to block 20 and remove the corresponding entry in the directory. It's very easy. And but there are multiple problems with like fat file system. First, small file access is slow because imagine like if the file is deep down in the directory structure, then file system needs to traverse each directory in order to get to the final file. Okay, and now when you go to the final file, we still need to traverse the linked list to go to the corresponding block. That's why random file access is very slow, because let's say I want to access let's say block 4 of file 1 of like file A, I still need to traverse from the first block because I don't know what is the fourth block of the file. Because everything is stored in linked list, I need to traverse the linked list in order to get to the fourth block. And this, like the flexibility of the file, like fat table, also results in fragmentation because the small file could have blocks scattered all around the place, especially when you do repeated file operations on the disk. Let's say you create a file, you delete a file, and you create directory, you delete a directory. This kind of frequent usages increases fragmentation in the file system so that the blocks that belong to a file could be scattered all around the disk. That could increase access time of a small file. Because imagine if the first block is in track 1 and second block is in, let's say, track 2. Okay? Even though file is of size just 2 blocks, there is a latency involved in the disk, right? So now the disk head needs to seek to the corresponding track and then read the corresponding block. So there is a delay. So in the next part, we will look into ext2 and how ext2 uh, surpasses all the disadvantage of fat file system.